All right. What we're going to do is we're going to look at lateral runout. This rotor's been set up with excessive lateral runout, about 2/10 lateral runout. That's huge. So we're going to turn the rotor so we get a good visual of what lateral runout looks like. Go ahead, Jess. So as the rotor's turning, you're seeing the brake caliper, and this is a floating caliper. The caliper has to move in and move out to accommodate the amount of lateral runout that this brake rotor has. If it was turning true, we would see the caliper stay exactly where it was, and we wouldn't see the rotor moving out. Okay, we're going to measure rotor runout on this Durango, and the first thing I need to find is the maximum runout spec. For this car, it is 0.004 or 4/1000ths of an inch. Once I've found my spec, I need to get my dial indicator, and I have my dial indicator on my cart, and I'm going to assemble the dial indicator to measure runout. So in the kit we have a dial indicator, and we also have a holding fixture. So I'm going to put the holding fixture on this set of vice grips. And I'm going to lock the dial indicator in the end of the holding fixture. So my tool looks like this assembled. Alright, I'm going to set the dial indicator up on this rotor, and you see that we have the vice grips clamping the knuckle down here. The next thing I got to do is bring the dial indicator up and touch it to the face of the rotor. And I want to have the dial indicator into its stroke. I like to shoot for about halfway. So when it's touching the rotor face, the indicator needs to be about halfway through its stroke. It cannot be bottomed out like this. If you don't have the indicator into the stroke, when you're spinning the rotor, you might not see all of the runout unless you have it in there a little bit. So we push the dial indicator up against the rotor, and now what I'm going to do is lock it in place with this lever down here. Put the dial indicator up against the rotor, and now what I'm going to do is lock it in place with this lever down here. If the lock does not secure the indicator, what I need to do is adjust this nut out, and that will tighten up the cable. Alright, so the way that I test my dial indicator to see if it's held in place is I just tap it at the top, and the needle should return to the same place every time. If I press the indicator and the needle moves and does not return, that tells me that my holding fixture is moving, and I'm not going to get an accurate measurement. So now that I have this secured, the next thing that I'm going to do is zero the indicator. Right here. Alright, so I'm going to return to my lowest number, right here, 31, and now I'm going to zero my indicator. I don't have to zero the indicator if I can do math, but by putting it on the zero, I don't have to add anything, and it's going to be easier to explain our measurement. So I line my needle up with my zero mark. And now I am at the point that is lowest on the rotor. So when I turn the rotor, I should see my total lateral runout on the rotor. We're at 2, almost 3. And then back just a little below 0. So we're going just below 0 and almost to 3. If I moved my indicator face and zeroed this a little bit better, we'd see 0.003 of lateral runout on this rotor. Our spec is 0.004, 4/1000ths lateral runout. So this rotor is below the maximum allowable runout. It's okay.